Thank you for your patience, and thank you for to the team for troubleshooting. I appreciate it. So I'm gonna have the objective today of convincing everybody in the room that collaborative AI is the future, and that by working in silos, you are going to fall behind and not take advantage of all the wonderful advances that you can in AI. So that's my objective. We'll see if we actually get there. And so I'll start with the old adage of, if you want to go fast, go alone. If you want to go far, go together. That's the underlying theme behind everything that we're doing today. There is a ton more to be done, both from a financial bottom line in terms of collaborative AI than there is from just working within one institution. And so I'll motivate this a bit using some very nakedly borrowed content from colleagues at the Boston Consulting Group, just illustrating the advancements of AI. And so you can imagine at the very beginning, where many institutions are today, it's very small use cases. You're just automating a business process that took somebody an hour to do before, now it's done automatically. Great, there's some value to be done there. You move up the value generation curve and you've actually started to optimize something, like you've changed something within your business process to begin with. Great, you're generating a little bit more. The most mature state is you're actually innovating, like you are generating an entirely new business model from AI as a result of being able to do something that you could not do before that you can do now. Unfortunately, most banks actually aren't getting that ROI. So too many AI projects are dying on the vine right now. And so the returns that we're seeing are not in line with all of the hype that is happening on the floor outside here. And a big part of that is because people are not actually working together. So a major stumbling block to actually having effective AI is you have enough data to run effective AI. And so there are a ton of very cool use cases that financial institutions should be collaborating on that would generate gigantic returns, but instead you have people that are focused very much on that first stage of that maturity curve. So we're only thinking about, oh, how do I cut out this one tiny little manual process because I can do the exact right AI model for it. Meanwhile, we're missing out on hundreds of billions of dollars of value for the global economy as well as for the bottom lines of financial institutions for applications that are huge social ills or opportunities. So you think about things like financial crime, so fraud prevention, anti-money laundering, mule account detection. These are big social issues that have connections both to costs for every person in this room, every business that's operating on the planet, as well as social implications. So money mules are being used to fund drug trafficking organizations. And so by collaborating more effectively, financial institutions from banks, insurance companies, et cetera, can add tremendous value, and we're not really focused on these because it's hard. It's really hard to do collaborative AI. It's really hard to do AI to begin with, and then you add in the layer of, oh shoot, now I want to collaborate with my competitor down the street. I want to collaborate with regulators. It's really, really difficult. But I'm hopeful that you can see, yeah, if fraud's a $500 billion issue and we can capture some portion of that by applying AI to it more effectively, that actually is a pretty good ROI versus, oh, fantastic, I was able to lay off 3 analysts in my business yesterday because I did this tiny little model. So I think it's way more exciting to think about these big, big applications. And so I'm hoping to then illustrate, okay, in order to make that a little bit easier, federated computing is the answer. And so I'll motivate that with an introduction to what federated computing actually is. And it's this intersection of edge computing, federated learning, and privacy-enhancing technologies. So edge computing is I am running workloads on edge devices rather than in one centralized area. Federated learning is the technique of training an AI model on decentralized data such that I can never actually move sensitive data, but instead I move model weights. And privacy-enhancing technologies are kind of a self-descriptive group, but the idea that even if I have the controls in place of edge computing or federated learning, there's still a host of other things that would make my CISO happy, that would make my DPO happy. And so how do we put some of these controls in place? And so putting it all together, you have this concept of federated computing. And so federated computing means I'm running a workload on data that I don't necessarily control. And this is extremely valuable if you think about applications of collaborative AI. And so some of the principles underlying this, so data always stays behind firewalls. So you are able to use all of your existing security controls because you always control the data. So this lives in your environment. It has benefits of your encryption. It has every control that you have in place. Instead, you send compute or code to the data that resides behind the firewalls. And so the only things that ever leave are insights. You move summary statistics or model weights or maybe telemetry data, but never actually row-level data. And so this, by definition, then builds in a lot of really wonderful aspects. So you get things like regulatory compliance. So for everyone in the room who's concerned about GDPR, if I want to work across silos, either organizationally or even intra-organizationally, that's really hard in a GDPR context where you have a European subsidiary trying to collaborate with somebody in Asia, trying to collaborate with somebody in the US. You can't do that by moving the data. But in the federated computing paradigm, that doesn't matter. You move the model. You train the model in Europe. You train the model in Asia. You train the model in the US. And then you aggregate the model weights. And all of a sudden, you've got an effective cross-silo model that benefits from the diversity of data across these different silos, but you've still maintained compliance with local privacy laws, which is a gigantic hurdle for this kind of endeavor. It also comes with improved security controls. Again, I mentioned all the data always stay under your control, and so there's you reduce the threat vector of actually having data in transit that somebody can intercept. And then there's cost and technical efficiency. So it can be very expensive to create duplicates of all of the millions of rows of data that are needed in order to train effective AI models. And so by actually just leaving data with the data custodian, you're able to take advantage of not paying egress fees, you're able to not pay additional network costs, and you don't need to pay for duplicative data. So it creates a little more sustainability, both environmentally as well as from a financial approach in terms of model development. And so, you may be saying, that's cool, but that's not super flexible, right? I like to have all the data. My data scientists like to have everything in their environment because they just want to play around with it, or there's a ton of data engineering that I actually need to do in order to make a model effective, which is absolutely true. Federated computing is not constrained to just the super clean data doing a model training exercise. So with federated computing, you actually can run a full end-to-end workload. So thinking through, all right, initially I need to do exploratory analysis to even understand what my partners have available for us to train a model on to begin with. Or I need to do exploratory analysis to understand, do you have sufficiently high quality data to begin with? Or do you even have data in the right format to begin with? So you can run all these queries across all of your partners using federated computing. Then from there, you can actually run your training workloads and you can do federated inference and still have the protections of encryption and privacy for each of those. Then you can go one step further. So you've solved the foundational issue around, I've done a basic exploratory analysis, I've done basic training, I can run inference. Fantastic. You're level 101 of AI. You want to advance to level 201, you want to start doing RAGs, you want to start having your own model garden and providing access to your partners and all sorts of other cool stuff. That's also possible through federated computing. And so this is really intended as the full end-to-end capability. And so I'll motivate what this looks like in the most basic, and then I'll give a financial services illustrative example. So to begin with, you actually do local training. So let's say 10 banks want to collaborate on fraud detection. Great, you would train that model in each one of those banks. The bank's data never move. The model moves to each one of the banks and then is aggregated in a common orchestration layer. And from there, you then let all of those banks who are participating run that model. So that's very simply said. If you can add a couple more layers of complexity, so in this example here, you'd say a financial market infrastructure organization is the one that's actually convening this consortium. So they do the aggregation of the model weights. They then make the model available to the participating banks. And then you actually get into something way more interesting from like a business value perspective, which is integration with your business processes. So great, we've got this fraud detection model. It's trained on a broader set of banks, and so therefore the model is going to be way more accurate. And now each one of those banks can run that model, again, in their environment, so they have control over what data it's touching and when they want to run the model and how they want to run the model. And then more importantly, in terms of actually generating ROI, you run the model, and then you have that connected to your workflows. So I run inference, and I have that then going to a fraud desk to say, oh, I need to actually do something with this. So it's the ability to connect end-to-end from that initial training into inference, into actually acting on the results of that inference, which is a really powerful combination that is missing from too many AI pilots today, which are, oh, this is really cool, we got tremendous model accuracy, but what'd you do with it? Nothing, right? It lives as an interesting research project and is not actually generating real business value. And so there are a few patterns that we're starting to see emerge with this federated computing ecosystem. So the first of which is financial market institution led. So you have an infrastructure organization like a SWIFT or a Euroclear or a regulator who actually says, hey, we see value in this. We are going to bring together a set of organizations that we would love to work together. We're actually also seeing peer-to-peer examples pop up, and I'll illustrate this. But so two banks, two insurance companies come together and say, you know what, I think we would be better off if we actually trained on more diverse data sets. You have great coverage here, I have great coverage here, let's benefit from that. Or AI vendor led. And so in this instance, we actually have model developers who are building their own consortia. And so they bring together a set of organizations and say, again, we'll all benefit from working together. We may commercialize the product, but you will get first right of access to the new product or discounted access to the product in exchange for having provided data to train the product to begin with. And then the last pattern that we're seeing are financial services organizations leading and building with that AI vendor. And so this is them saying, I don't trust you, but I want to work with you. And so I'm going to use federated computing as the tool that will give you access to my data because I know I can do it in an ecosystem that I still have lockdown control over. So this is, I'm going to run federated inference of your model within my environment. And so we're seeing these examples pop up. What we have on the page here is primarily in the banking sector, but you can generalize the pattern across financial services. So JP Morgan and Bank of New York published a paper earlier this year or late last year demonstrating that they saw a tremendous model lift when they participated in a federated learning experiment. BIS has put out a call where they see the novel value of federated learning, and this is one of their kind of strategic aspirations over the coming year. Monetary Authority of Singapore has experimented, and then a project that we're proud to be a part of is actually with SWIFT. And so we're working with SWIFT to build a consortium for fraud detection and for mule account sharing. So, hey, I've identified this as a mule account. I should tell people, right? And so we get to actually see the benefit of this collaboration. But I'll say financial services are still experimenting, and other industries are pulling ahead. So we, as an organization, actually work across a few different sectors, and we're seeing life sciences in particular is starting to pull away from financial services when it comes to actual production use cases of AI. And so the example that I'll highlight is a program that we're helping to build with Eli Lilly, where Eli Lilly aspires to work with all of the biotechs in the world. Not some, all of the biotechs in the world. So 8,000 biotechs, they want to build a program where all of them are collaborating on AI development. And so Eli Lilly is building a collaborative ecosystem in which the biotechs contribute some of their data for training of new models, and Eli Lilly is providing hundreds of millions of dollars of AI models to those biotechs in exchange. So a really, really beautiful collaborative ecosystem that's being facilitated on what are literally the crown jewel IP of each of these organizations in terms of those biotechs with their molecules and Eli Lilly's gigantic AI assets. And so this is a production workload that is live today, which is super exciting to see. Nothing like this is existing in the financial services space right now, and I think this is a call to action where folks in this room and elsewhere should start to say, you know what, there's something here. We're seeing a super conservative, super paranoid organization like Eli Lilly be willing to take a gamble on this. Maybe federated computing actually holds the answer for us to develop as well. And so this is a illustration of what that workflow looks like. So in this case, each one of those biotechs contributes some data into a cloud storage bucket. They're able to then run inference from an Eli Lilly model garden within that storage bucket that they have total control over. And then the next piece will then be the training of net new AI models that Eli Lilly wants to fill gaps in their portfolio on. And so how does this actually work? A big part of what I'm saying is in order to actually capture value from AI is doing this collaborative AI approach, but I will totally admit this is not straightforward. It's quote unquote very easy to say, I've got a ton of data internally, I'm gonna train a model and show that it's cool. But in order to put stuff in production, especially with this federated computing paradigm, there are some steps you need to take. And so the broad 5 steps that I would say are important for you all to remember. The first of which is have your compliance team broadly be happy. So legal, privacy, security are critical. Coming up with consortium agreements so that everybody's very comfortable with IP ownership, so that everybody's comfortable with the security posture of the resulting pattern, absolutely important. From there, you're working across organizations who probably have different data models, and that makes a pretty challenging environment to work in when your data scientists are actually spending 50% of their time cleaning data or doing data engineering or feature engineering. That's a pain in the neck. How do you actually make sure that you've specified the data schema that everybody should be working in? How do you build the appropriate ETLs in order to make sure that those data then live within those schema? It's not an easy challenge, but there are products out there that can help with that data harmonization in order to make sure that you can take advantage of this kind of collaboration. The third is then the MLOps orchestration. So there are several different open source federated learning frameworks to work with. Rhino partners really closely with NVIDIA. We use the NVIDIA Flare framework as the foundation of our product. And then the Rhino product actually acts as an orchestration layer on top of that. Then production deployment. So thinking about how do I actually go from model training runs to then how do I connect the results of the model training or that inference into my environment and making sure that you have, again, the appropriate pipeline to capture signals and then push those signals to people who can do something. And then fifth is program management. Collaboration is a challenge. Managing or herding the cats of your fellow consortium members is not necessarily easy, and so having in place appropriate program management mechanisms for how do we do ongoing governance of the collaboration, how do I bring new partners on board, how do I get people trained to be part of this ecosystem, how do I make sure that there's institutional knowledge for what we're doing and what's the mechanism for approving the next project that we're going to be working on. So taking together all 5 of these steps then really should get you from I have a bunch of partners. There's a big problem we might want to solve. This is the playbook for how to actually solve that that problem with that set of partners. And so I mentioned again, this is can serve as your call to action. There are a bunch of pilots that are in progress. So I mentioned SWIFT. I mentioned the Bank for International Settlements. Both of them are engaged on programs right now that I think are welcoming new members. You can start a consortium yourself if you are super ambitious, but those are some ready-made groups that you might join. And then you can start playing around with open source federated learning on your own or connect with the Rhino federated computing team to learn a little bit more. And so with that, I'll stop presentation, but glad to answer any questions if folks have them. All right, thank you very much. Have a good afternoon all.